materials who have the dipole moments aligned in opposite side but with different magnetization. So net dipole moment is non-zero. So this is the definition. Then one has to write down the properties of at least two properties of ferrites, and we have to write down the uses of ferrites, the application of ferrites in various things. Ferrites can be used as a permanent magnets, as well as they can be used in computer memories. They can be used to store different types of data, right? So these are different applications or say uses of ferrites. Question number 4, A, define and discuss the given factors, those are 4: reverberation, loudness, echelon effect and noise, that affect the acoustics in a hall and the remedies of them. There are 4 factors given. You will have to write down, you will have to define them, as well as you will have to write down the remedies, right? First is reverberation. What is reverberation? Reverberation is the remnants of the sound in the room even after the source is cut off, and it should be, the reverberation time should be at its optimum value. If it is not kept, then one has to take some remedies to make the reverberation time at a particular value. What are the remedies? One can use curtains. We can cover the noise producing materials with some curtains, as well as with some noise absorbing or say sound absorbing materials. Walls can be designed in such a way that they may be porous walls, so extra noise, extra sound can be absorbed. Okay, and second is loudness. Loudness is very important factor which affects the architectural acoustics. It is defined as it is defined in terms of the loudness level. Loudness level is IL is equal to 10 log of I upon I0, right? Loudness should also be maintained at a particular level, because in order to have uniform or adequate sound in the whole room, in the whole hall, one has to maintain the loudness. And what are the factors that can maintain the loudness? One should avoid the corners or curvilinear surfaces in the room, as well as one should use enough microphones in the room, speakers in the room, right? So these are the remedies. The third one is echelon effect. Echelon effect or echelon effect, it happens in the room due to the continuously varying surfaces like stairs or like curvilinear surfaces. So the sound waves, they will be continuously reflected by such surfaces, and the reflected waves, they again superimpose on each other to create some type of confusion. So to remove the echelon effect, such curvilinear surfaces or such continuously varying surfaces like staircases, they should be covered with some carpet, and adequate sound absorbing material should be installed in the room. The fourth one is noise. There are actually 3 types of noise. First is airborne noise, then structure borne noise, and then inside noise. All the 3 factors, they can be removed with adequate remedies. Airborne noise, the room should be soundproof in order to avoid the airborne noise. The structure borne noise can be avoided by choosing the place of the hall away from from highway or railway stations, so that the structure borne noise can be avoided. The third one is inside noise. If there is an air conditioner or refrigerator or any other instrument which makes noise inside the room, then it will be the cause for inside noise. Such instrument should be covered with appropriate say curtains or covers, or they can be covered with some noise proof materials. Okay, so next one, the volume of a room, it is actually an example, so we will move to the papers. First of all, we will list down what are the quantities given. The volume of the room is 1500 meter cube. The wall area of the wall is 260 meter square. Area of the floor is 140 meter square. Area of the ceiling is again 140 meter square, right? What about the absorption coefficients of this particular materials? The average sound absorption coefficient of the wall is 0.03 Sabine. The average sound absorption coefficient for ceiling is 0.8 Sabine, and the average sound absorption coefficient for floor is 0.06 Sabine. Now we will have to find out what? We will be finding out A bar, that is the average sound absorption coefficient for the whole room, and the reverberation time T. Okay, A bar, for A bar what should be the formula? A bar is equal to A1S1 plus A2S2 plus A3S3, that is the sum of sigma of AISI divided by sigma of S, that is S1 plus S2 plus S3. Here we have used the notation A for area, so it is S1, this is S2 and this is S3. Okay, so A1S1 is what? A1 is 0.03 multiplied with S1, that is 260, plus 0.06 multiplied with 140 plus 0.8 multiplied with 140 divided by the sum of all the areas, that is 260 plus 140 plus 140. And with this, what is the answer, friends? By calculation one can get this as 237.4 OWU, that is open window unit. Okay, this is the first one, A bar, that we have found. Now we will find out T. The second one, T is equal to, what should be the formula? 0.167 V divided by A bar into sigma S or sigma over SI. 0.167 multiplied with 1500 meter cube. A bar is 0.2374, we have got it already, and the sum of all, that is 540 meter square. So answer is T is equal to 1.954 S. Okay, that is second. The reverberation time here is 1.954, so the answer you can write it down as A bar is equal to 0.2374 OWU and T is equal to 1.954 second. If you make this type of boxes in the exam to highlight your final output, then it will be very easier for the examiner to evaluate the answer sheet, right? Okay, we'll move ahead. Next question, B of 1. Describe any two characteristics of the musical sound. There are actually major three characteristics of the musical sound: pitch, timbre and loudness, but one has to describe any two. You can choose any two of three here to describe them. Pitch can be defined as it is actually higher the frequency, higher the pitch. These are actually characteristics of the musical sound. So related to musical sound, they can be defined. The pitch distinguishes the sound as shrill or grave. The timbre, it differentiates the notes of same frequency emitted from the different sources, and it helps identifying different persons and instruments sound. Right? Where loudness, it signifies how far and up to what extent the sound is audible, and it is a subjective sensation. All the three, they are subjective sensation, they are physiological quantities or say psychological quantities, but the quantities on which they depend upon, they are actually physical quantities. Pitch depends upon frequency, timbre depends upon the quality of the sound, and loudness depends upon the intensity of the sound. So you can describe any two of the three. Next one, what are the biomaterials? Explain the different types of biomaterials and their applications in the medical field. They have specified that biomaterials application should be in the medical field. We will have to define biomaterials. Actually, we will have to define initially the biomaterials. Biomaterials are the materials which are used for either for implantation to the human body or for some different types of medical diagnostics. They can be used as, again we will have to write down the application, so they can be used for teeth implantation, or can be used for heart valve implantation, or they can be used in knee implantation operations, right? So these are the different applications of the biomaterials in medical field. We will have to also explain the different types of biomaterials. There are actually 3 types of biomaterials: biodegradable, usable, reusable biomaterials, and this question carries 2 marks, so you can write down any 2 applications of the biomaterial and the definition. Next one, explain with neat circuit diagram the generation of the ultrasonic waves by magnetostriction oscillator. So first one has to, it carries 3 marks, so one has to write down the principle of the magnetostriction oscillator method. What is the principle? Principle says that when a ferromagnetic material is subjected to an external magnetic field, it will undergo the dimension change. So under the effect of a magnetic field, the ferromagnetic material, if the natural frequency of the ferromagnetic material and the external field frequency, if both are equal, then there will be a resonance and ultrasonic waves are generated. So this is the principle of the magnetostriction oscillator method, and then one has to draw the diagram of the magnetostriction oscillator method, and one has to explain the method in detail with construction and working. So in order to get 3 marks, we will have to write down the answer in order of principle, figure or say circuit diagram, and construction and working. Next one, question number 5a1, define superconductivity. Write definitions of the 3 important factors to define a superconducting state. Also discuss few important properties of the superconductors. What is a superconductivity? This question carries 4 marks, so each of the section carries 1, 2 and 2 marks, 1, 2 and 1 marks. What is superconductivity? It is the state of the material in which the material conducts with 0 resistance. So up to a certain temperature, material can conduct with 0 resistance. If that temperature is attained, then the material will behave as a normal conductor. So there are 3 major factors which can define a superconducting state. What are those? First is critical temperature, second is critical field, and third is critical current or critical current density. So TC, HC and JC, they are the 3 important factors which can define the superconducting material. Up to a certain critical magnetic field, the material will behave as a superconductor. After that, it will be in its normal conducting state. The same way for current, up to a critical current, it will be in its superconducting state, having no opposed to the current, say 0 resistance state, but after that it will be in its normal conducting state. It will offer the resistance according to its properties. The few important properties of superconductor are: first is 0 resistance, another is persistent current, another is Meissner effect, another is isotope effect. You can write down, actually there are 6 or 7 such important properties, but you can write down a few of them in order to get 1 marks. Next one, the critical temperature of the niobium is 9.15 Kelvin. At 0 Kelvin, the critical field is 0.196 Tesla. Calculate the critical field at 6 Kelvin. We will move to the paper again in order to calculate this example. First of all, we will list up what are the quantities that we are given. The critical temperature of niobium is 9.15 K. So Tc is equal to 9.15 Kelvin. Okay. At 0 Kelvin, the critical field, that is Hc0, this can be annotated by this symbol. Hc of 0 is 0.196 Tesla. Okay. And what we will have to find out? We will have to find out Hc at 6 degree Kelvin. Right. So the equation that we can write down here in order to find out HCT at a particular temperature, the critical magnetic field can be found with Hc of 0 1 minus T by Tc the whole square. Substituting the values, Hc of 6 is equal to Hc of 0 is what? 0.196. 1 minus T by Tc the whole square. T is what? Here we are given T as 6 Kelvin. So 6 divided by 9.15 the whole square. And the answer is, with the calculation, it is 0.1117 Tesla. So the critical field at 6 degree 6 Kelvin is Hc6, that is 0.1117 into T. Sorry, 0.1117 Tesla. Okay, now next one, 5b1, compare type 1 and type 2 superconductor. Marks are 2. So any 4 points you will have to write down. Type 1 superconductors and type 2 superconductors, they are the result of the classification of the superconducting materials based upon their properties. Type 1 superconductors are soft superconductors. Type 2, they are hard superconducting materials. Soft superconductors means they have only one critical magnetic field Hc. Type 2, they have two critical magnetic fields Hc1 and Hc2. For type 1 superconducting materials, Hc has a bit lower value than the with respect to the critical field of hard superconducting materials. In hard superconducting materials, since Hc1 and Hc2 are there, they have a very higher value of Hc2. Now for soft superconducting materials, there is no intermediate or vertex state. At Hc2, upon reaching Hc, the superconducting state will be removed, the material will gain its normal state. For hard superconducting materials, the material will be gradually leave its superconducting nature and moves to the normal conducting state. So the intermediate state is known as vortex state. So these are the major 4 differences. You can also write down the examples of 2 different soft and hard superconducting materials. Even you can draw the graph showing the change in the magnetic field at a particular temperature for a superconducting for both types of superconducting materials. Question number 2, what is solar cell? Discuss a few materials that are used in solar cell design. One has to write